Hi everybody, Mary here, and we are going to talk this time about ions. An ion by definition is a charged atom. So this is an atom that is either positively or negatively charged. By definition, an atom is neutral. It has the same number of protons as electrons. But if it loses electrons, it is going to have more positively charged particles in its nucleus, so it will be a positive ion. If it gains excess electrons, it will be a negative ion. And so ions can be positive or negative depending upon how many total particles are inside of that little ion. If it is a positive ion, it can also be called a cation, and if it is a negative ion, it can be called an anion. Now, these two words, cation and anion, are vocabulary words that you are responsible for knowing. And for me, through the years, it was tricky keeping track which one was positive and which one was negative. So this is how I remember them. The word cat is in cation, and this is a picture of my kitty cat, Maudie. And so I am positive that that's a picture of a cat. And so whenever I see a cation, I remember that I am positive it's a cat. So positive ions are cations. And in the word anion, there's an N. N reminds me of the word negative, and that's how I keep them straight. It's silly, but hey, sometimes silly works. So we're going to find the most common ion that's produced by sodium. Keep in mind, atoms make ions in an attempt to have a full octet or a full outer energy level. This is back to that octet rule. Atoms do everything they do in order to become stable. So that's the background, that big idea that we are working on. So if we look at sodium, sodium is right here in group 1 on the periodic table. And if you round off the atomic mass of sodium, it is 23. The atomic number of sodium is 11. And that means sodium is going to have 11 protons in its nucleus. For an atom of sodium, it's going to have 11 protons, 11 electrons. And if we subtract 23 minus 11, 12 neutrons. So the 11 protons and the 12 neutrons are going to hang out in the nucleus. Now the electrons are on different energy levels. The first energy level, so we've got 11 electrons. The first energy level will hold a maximum of 2. So I'm going to put 2 electrons on that first energy level. There are 2 rules, one called Hund's law, the other one called Pauli's exclusion principle, 2 of which are quantum mechanic rules that we're not going to go through in this course. It's kind of beyond our class. But those explain why electrons cuddle up together in pairs in these lower energy levels. So the first 2 go in that lower energy level, and that's going to leave us 9. So the next energy level will hold a maximum of 8. So I'm going to take my electrons on the next level, and electrons have a tendency to go all the way. One, they spread themselves out. Why do they spread out? They're all negatively charges, and negative charges don't want to cuddle up together. And then after they spread out, then they start pairing up. Electrons like to pair up. So now I have used 2, 4, 6, 8 on the next level, and I have 1 out of my original 11 that's left to go on the last energy level. Now remember the big goal, the big idea. Ions want a full octet. They want a full 8 in their outermost energy level. So for sodium to be stable, it's got to do one of 2 things. It either has to let it go of this 1 electron, or it has to gain 7 more electrons. Well, gaining 7 more electrons is really, really hard because other atoms don't want to give you 7 electrons. They're like really precious things. So sodium holds on to this electron, not really hard, just it holds on to it, but kind of wishy-washy, not a strong electrical force that's holding on to this electron. So this electron is easily taken away by other things. That's what makes sodium very reactive. And that's what makes this whole family here very reactive. So if it loses 1 electron, if this one is let go, then you end up with 10 electrons, 11 protons, and you end up with one more positive than negative. And the most common ion of sodium that's produced has a charge of positive 1. Let's take a look at another one, chlorine. Chlorine is right here in the halogens, group 17 on our periodic table. Chlorine has an atomic mass of 35, if we round that off to a whole number, and an atomic number of 17. So 17 protons, 17 electrons, subtract 18 neutrons. So the nucleus is going to have 17 protons, 18 neutrons. First energy level is going to have maximum of 2. So I'm going to put 2 electrons in that first energy level, leaving me with 15. Next energy level, maximum of 8. So we go around once. 1, 2, 3, 4, 5, 6, 7, 8. So I've used 8 and I have 7 to go. So the next energy level, I'm going to put those 7. I'm going to draw them off a little bit so we can kind of see them. 1, 2, 3, 4, 5, 6, and 7. Now remember the goal. The goal for any atom is that octet rule. They want 8. 8's the magic number in chemistry. And chlorine has 7 outer electrons. It has an empty spot. And it is holding on very, very tightly to all 7 of these outer electrons. It has a lot of electrical charge towards that nucleus. It's really pulling hard and it wants one more. So to get that 8, it either has to lose 7 or gain one more. What makes chlorine so incredibly reactive is that it's very good at gaining one more. So if it gets one more from someplace else, and we'll show you how that happens in a moment, it's going to end up with 17 protons in its nucleus, and instead of 17 plus 1, 18 electrons. That's going to make it have one negative charge, and chlorine is going to have the most common ion of chlorine, -1. So what happens if you mix sodium and chlorine together? Well, sodium is sitting here with 1 electron that it's holding on to kind of wimpy. Chlorine really wants 1 more extra electron. So if you put sodium atoms and chlorine atoms together, you're basically making table salt the hard way, because this electron, sodium electron, will be very strongly pulled by chlorine. And this is going to make this sodium ion, +1, this chlorine ion, -1. And we are working on making an ionic bond. Now, the ionic bonding process is a 2-part process. First thing that happens is this electron transfer. The electron goes from one to the other, and then you end up with a positive ion and a negative ion. Then you have an electrical attraction. This is positive, this is negative, and you and I both know from electricity that opposite charges attract. And the opposite charge attracting between the positive and the negative makes what we call in chemistry an ionic bond. And this ionic bond is what holds table salt, sodium chloride, together. Another big idea, huge big idea in chemistry, and that's this. When you go through this process, ions have very different chemical and physical properties than the elements that make them up. So let's talk about sodium, chlorine, and sodium chloride. Sodium we've talked about a handful of times. It's a soft, shiny metal. If we react it with water, it's violent. You certainly would not want to get this near your skin. Chlorine gas is a yellow-greenish gas. If you would inhale it, it would be poisonous and deadly. And yet, once both the sodium and the chlorine are in ionic forms and they bond to form sodium chloride, we get something that is yummy on French fries. Many of us put it on our food. And it is essential, so essential that patients in hospitals are not just given IV solutions of water, they are given saline solution, because our bodies need the electrolytes. We need these salts to help our bodies process. So we go from two things that are deadly. By making ions out of these sodium and chlorine atoms, we have created a different set of physical and chemical properties that make them essential and necessary for the body. What I'd like to have you do on your periodic table is write at the tops of the columns the most common ions produced by each main group set of elements. Now, the main groups, if you recall, these are the two towers on the right and left side of the periodic table. We'll deal with the transitions in another lecture. Metal ions, metals tend to produce positive ions. Metals tend to lose electrons. So group one right here tends to produce +1 is the most common ion produced by that family. Group 2 makes +2. We're going to skip the transitions for now. Group 3 makes +3 ions. If we go to the nonmetals on the far right-hand side, these tend to make negative ions because nonmetals tend to gain electrons. Group 17, the halogens, tend to make ions that are -1. Group 16 make ions that are -2. Group 15, -3. So what do we do about group 14 right there? And the challenge is we've got this wacky stair-steppy line where the nonmetals are to the upper right and the metals are the lower left. What do we do with that division? Remember, metals make positive ions, nonmetals negative ions. That's the trend. And so for group 14, I'm going to ask you to write plus or -4, depending on if it is a metal, it's going to be positive, and a nonmetal, negative. And we're going to use this information for the rest of this week and in the future as we talk about ionic bonding. All right, that will do for this time, and we'll see you later. Bye-bye.